Hey everyone, welcome back to another Web Dev Junkie video. My name is Cody Seibert, and in this video I want to give you an overview of what AWS is, which stands for Amazon Web Services. And then I also want to kind of explain why you might want to use it, and then I'm going to give you a bullet point list of all the various services we use on the current project that I'm working on. So if you don't know what AWS is, I guess it's important to talk about what happens during the software development process, right? So you typically have a team of software engineers who build a product, and at some point they need to host that product somewhere, right? Software only runs on machines, so you have to have a dedicated set of resources to run your web application, and that is where Amazon Web Services comes in. They basically provide you a ton of different things that you could potentially use to help implement your product. There's a lot of stuff to cover, and I'm not going to cover all of it because it is pretty daunting, but I want to show you that it's not too hard to hit the ground running with Amazon Web Services and just give you an overview of what you could learn. So I'm kind of just rambling now, but this is the landing page where you can go create an account, and if you create an account, you get basically 12 months free for some particular services, right? So read the fine print. Sign up for an account, you can start messing with S3 or EC2, and I'll explain all these services in a bit. So why would you want to use AWS? Again, if you have an application that you need to host somewhere, you have the option of getting a dedicated box somewhere. So you might want to pay $100, $200 a month to get a really powerful dedicated machine, and you can host your servers on there. Or you could maybe take a step back and do like virtualization. So maybe you can go to DigitalOcean or Linode and order a smaller machine that has maybe like a gig or 2 gigs of RAM and maybe 2 cores. And then you can host your application on that and then manage all that yourself. Amazon Web Services is just another solution where you can go in, you can rent a dedicated machine of 1 gig all the way up to 32 gigs or 128 gigs to run your application and do what it needs to do. And if you're starting out, if you're a startup, you may or may not want to use AWS because some services are really costly, but they do offer a ton of different things. So if you're a larger corporation, then AWS is a great solution because if you need something, I don't know, like sending emails or doing Elasticsearch or database or spinning up servers or doing serverless functions, they have all of it, right? And I think Microsoft has Azure, and Google probably has something as well. I haven't used the Microsoft solution. I haven't used the Google solution. I've only used Amazon because it is like kind of the leading cloud service out there. All right, so I don't know if I gave a good overview. I hope I did. Sum it up in one word. It's a service you can pay to host your code, right? That's basically how you sum it up. All right, so I have an account that I'm logged in right now on the right, and I want to step through and kind of give you an overview of all the services we use at work. So again, to understand like why you might want to use this, you kind of need to understand how software is built and how it's ran, okay? And the various components that go into building large-scale software. So all of these are services that we use on AWS currently at work. Okay, and stuff down here is stuff that I have touched in the past, or I've done on different projects, or I've experimented with. And there's some others that I'm not going to go into as well. In fact, I haven't even done code deploy, so let's just delete that one. And I'll show you there is a ton of stuff. So I'm just giving you an overview, explaining what these are and why you might want to use them when you're kind of deploying your application. So when you log into Amazon, you made an account. There's a ton of stuff you can do, so it's kind of overwhelming. You see the services drop down. If you click this is basically all of the services that you can use on Amazon. There is a lot, okay? So it might be very overwhelming at first, but once you start using them, you realize it's not as scary as it might seem. And you don't really need all of these. It really depends on what your application is doing. Like I don't touch most of any of these except for the ones that I have over here. So what I'm going to do is let's just start talking about the ones I use and why I use them at work, or why we use them. Since I work on a team, I shouldn't say I. So the first one, this one is a really well-known one. It's called S3. So S3, if you go to the S3 dashboard, it's a service that allows you to create something called buckets. And inside these buckets, you can store files. Okay, so you can store PDFs, you can store images, whatever you want to store, JSON objects, JavaScript files. You can host entire websites, like HTML websites, inside of a bucket. So yeah, this is definitely great. So a good example of this is you have an application where a user needs to be able to upload a file and you need some place to save it. Okay, so you might want to use S3 to store all the files, because if you try to store them on like a running service's hard disk, you're probably going to run out of space. So for S3 buckets, you have like syncing, which is pretty cool. You can create a bucket in like an East region and a West region, have them sync together. You can create a bucket and tell it to be host an actual like website. So I could actually create a bucket here, upload some HTML, and then I can go and view it on a URL. And it's also pretty cheap to host stuff on S3 and store stuff in S3. What other cool things do we do with S3? Yeah, so you can do triggers. So whenever a file is actually put into the S3 bucket, that can trigger something in Amazon and, you know, fire off a Lambda or fire off some other code, and you can do stuff and just monitor like when files are being added or removed or moved around in your S3 buckets. So again, why do we use this? Basically, if you need to store some files, this is just an infinitely large storage space that you can put stuff into and retrieve later. And there's a lot you can do with permissions with the buckets to make them private so that not anyone can just grab stuff. But I think that's enough of an overview of the buckets. I'm not going to go in and actually like dive into the details of these. I just want to give a high level overview. So yeah, this one is probably the most important, or one of the most important ones. So CloudFront. So if, let's say you're building a UI and you want to host it on S3, so you basically have your React app, you build it, you get a disk folder. Inside that disk folder you have like index.html, and you have your JavaScript files, your HTML and CSS, whatever. So you can take that entire zip and kind of upload it to an S3 bucket, and then you can say that that bucket is a public bucket, okay? Which allows you to basically access it with your browser. So CloudFront is something that you can point to that bucket, or there's other origins you can point to, but in this example you can point CloudFront to your bucket, and what CloudFront does is it basically takes your UI and it hosts it all over the globe. Okay, so let me take a step back. So when you put your application in your bucket, usually it's only in a single region, right? It might be in like US East, or it might be in US West or something. It's typically just stored in a single region so that, you know, it might be quick to load for someone who's living in New York if you happen to be in US East 1, but someone in Asia or India, it might load really, really slow because the latency between, you know, New York City to India might be 500 milliseconds or a second or even greater. So again, what CloudFront does is basically takes your files, it distributes them across the entire globe to many different CloudFront nodes, or I don't know what the terminology is, so that if someone tries to access your site from India or Europe or Asia or Russia, it's going to fetch it from the closest node in terms of latency, and your app will load really quick. Now I say your app, I mean your UI, okay? So it's good to put your files, your images, your CSS, your JavaScript behind CloudFront so that when people try to access your UI, it loads up fairly quick. And I'm sorry, I'm talking about CloudFront and I didn't even go to it, so let me just go to CloudFront. Alright, so CloudFront, you basically create a distribution, and then in that distribution you can point it to an S3 bucket, or you can point it to other things, I believe. And there's a couple of, you know, tweaks that you can do. I'm not going to get into that because it is kind of complicated. But yeah, basically you'd want to use this if you want to pretty much provide really low latency for your static content. That's a whole nother discussion, what static content is, stuff like that. But we use this at work. We put our UIs behind CloudFront so that whenever people try to access it, it's quick depending on where they're living on the planet. So the last step is if you're trying to load like a UI, you might want to use a Route 53 service. So let me just go ahead and go to Route 53 before I forget. And so Route 53, you can create something called zones. And let's say you buy a domain on like namecheap.com or something called codycyber.com. what I can do is I could point a subdomain, or I could point the entire domain to Amazon. And basically you can allow Amazon to manage all your domains, like your subdomains and stuff like that. So why would you want to do that? Well, imagine you have an application that has a WebSocket server, you have an API, you have S3 endpoints, you have Elasticsearch endpoints, you have database endpoints, and you want all those to be managed behind the same subdomains, right? You might have like api.codycyber.com. You might have like ws for websockets.codycyber.com. What Route 53 allows you to do is basically manage all those domains and subdomains and point them internally to the various Amazon products or services. So as an example, what we do in our project is we have, our API, we have a subdomain that points to the API, we have a subdomain that points to a WebSocket API gateway, a subdomain that points to our Elasticsearch index, a subdomain that points to our API gateway for our Lambdas. I don't know if I said that already, but a lot of stuff you can do, and you can also use this for like certificate validation. You know what? Let me put that in before I forget. That's an important one. All right, so Route 53 basically just a way to manage your domains and point domain names, A records, C name records, stuff like that to various stuff in Amazon. Hopefully I'm explaining this well. I'm not like I didn't really prepare for this. So let's just take a step further. We use these three. We use all these at work. So let's move on to EC2. So we have the previous three services, S3, CloudFront, and Route 53. Those are really useful for hosting, like, let's say, a UI, a static UI or something. Now moving on to more the back end, we have something called EC2. EC2 is basically where you go to create your virtual machines. Okay, so you can go into instances. I can create a new instance here, and I can say, give me a machine that has 4 gigs of RAM, 2 virtual cores and stuff like that. And obviously all APIs and services need to run on some type of server itself. So what you do is you go in here, you might want to select your operating system. They have a ton of different operating systems that you can run on your machines. I'll just click the first one just to kind of show you. And then once you do that, you have this selection. So these are all the various EC2 instance types you can pick from. Okay, so notice some of them have like 96 gigabytes of RAM. Is that memory? Let me check. No, those are CPUs. 96 CPUs, okay? And 384 gigabytes of RAM and almost 2 terabytes of solid state. So there's a lot of different types you can use, and honestly, depending on the application that you're using, I don't know, maybe you're doing like insane artificial intelligence, neural network computations. I don't know why you need something that big. Mainly, if you're beginning, if you're a starter, I would definitely go with the micro. You get 1 gig and 1 CPU, and you could easily host like a node service on that. You could host, I don't know, PHP or something like that on. You could probably even host MySQL. Yeah, so you got all these choices, and be careful. Make sure you look at the pricing, because if you were to accidentally spin up one of these ones that have like 96 cores, you're looking at probably like $1,000 a day, or probably more than that. So be very cognizant of the pricing of these different things. And if you accidentally spin one up and leave it running for 48 hours, you might have a $20,000 bill in your Amazon account. So be careful. So to wrap that one up, EC2, basically it's a way to create actual virtual machines in the cloud that you could then SSH into. You could deploy your code. If you're using like, let me take a step back. So you would probably want to use EC2 if you are using something like Puppet or Chef or Ansible, and you want to kind of manage your machines with those type of, what are those even called? Like orchestration tooling. If you just want to host a server, EC2 is pretty cool, but they're kind of pricey. I typically use DigitalOcean to host my own personal projects because it's a lot cheaper. Yeah, but if you want everything in the same ecosystem, you might want to use EC2. Anyway, let's just move on. I think I've kind of talked about that. So Fargate. So there is, I think it's called Fargate. I think they called it Elastic Container Service. ECS? No, hold on. I think it's called something else. Oh wait, I guess it is the service. There's Registry. I'm sorry, I'm trying to give you guys an overview and I'm clusters. I think ECS is the running one. ECR. Okay, so there's one called Elastic Container Service and Elastic Container Registry. You can call me out if I'm wrong on this stuff. But Elastic Container Registry, which is this one, is where you go to store your Docker containers. So let me take a step back. If you don't know what Docker is, it's basically a way to like package up your application into a Docker container, or like this little self-contained thing that you can run inside of something called Docker. Yeah, I don't know, just read up on Docker. It's just a way to virtualize your code, virtualize your infrastructure and containerize it so that you can have like, you know, let me give you an example. So if I had Docker running on this machine that I'm using right now, I could technically have like 4 different Docker containers running, and each of them could be their own operating system, and they could each be hosting their own like web application. One could be hosting a PHP application, one could host MySQL, one could host Elasticsearch, and one could host my UI or something. But they're all isolated in terms of like they can't talk to each other. They're all their own separate like running containers, all on my desktop. I don't know if that was a good overview, but it's basically a way to like virtualize what you're running. I don't know, find a different tutorial. Someone else can probably explain it better. But a lot of people use Docker at work because it makes development and deployment really easy. So ECR is where you basically deploy those Docker containers that you built to. That's about it. You make a registry, you send your containers up there, and then at some point you need to run them. So if you go to ECS, Amazon Elastic Container Service, you can actually host them, okay? So you could basically point, I think there's, yeah, Fargate, okay. You basically create like an application definition and you point it to that Docker built image, that image that you built, and you put in ECR, and you can tell, you know, Fargate, which is ECS, to basically spin up 20 instances of it. Maybe you can do some auto scaling, so if it's getting a lot of traffic, you could scale up and scale down. We don't really use this one at work. I think we're about to use it because we have to do something that I don't want to get into, but I think we're gonna have to look into this. And we already use ECR, but we probably need to actually host something in ECS. And again, it's just if you want to use a Docker container and Docker to run your application, you probably want to check this one out. Yeah, I don't know if I really explained this one too well. Sorry, y'all. So let's move on to something I can explain, which is Lambda. So Lambda is another service that Amazon provides, and this is all about serverless computing. So the previous things I talked about, EC2 and ECS, you actually have like a dedicated amount of resources just sitting there, right? Just sitting there and running. So even if no one is touching your application, no one's hitting your UI or logging in or doing anything, you're still getting charged for just having that service running, having that memory being consumed, that CPU being consumed. So Lambda is a serverless solution, meaning that you only pay for what you are really using. So if you have your application hosted out there and only 2 people hit it that day, you're only going to get charged for those 2 invocations of your Lambda functions. So what you can do is typically you have like a REST API and you have a bunch of different endpoints, let's say 20 different endpoints. What you could do with Lambda is you deploy 20 different Lambda functions, right? So they all are ran and spun up individually, and they all process some requests, and they can send back some requests to the user who's trying to use it. And we use this extensively at work. We use this all the time, and it really can save you a ton of money. So I definitely, out of all the services on Amazon, I really enjoy using S3, and I really enjoy using Lambda. Okay, there's a couple others I like too, but these are actually like really cool technologies to play around with. So out of all the things I talk about, definitely check out Lambda, check out S3, check them all out, obviously. But again, yeah, this one you can trigger functions from various things in Lambda, like for example, S3. Remember I talked about when a file enters the S3 bucket, you can trigger something? Well, you could trigger this Lambda function to process that file, maybe read through and filter out any bad words that you see in the text file, and then store it back in the S3. You can do a lot of cool stuff with Lambda, and it's really cheap. Okay. You can create a function. I think it can run like PHP, not PHP, can it? I think it run Python, Node, Ruby. So you can basically write your code with whatever language that they support, and then just process the code that comes in, process the data that comes in, do some stuff. And while I'm on that topic, there is a library called Serverless that we used for a while, but then we decided to get rid of it because it was just a mess. But if you're starting off with just like a little, where are the docs? Here they are. Yeah, so if you're starting off with like just trying to get your feet wet with serverless and how to deploy these Lambda functions, I would definitely check out the serverless framework. It basically is a way to like, I think it might only be for Node, I don't really know, but it makes it really easy to deploy your Lambda functions and host them behind an API gateway. Okay, so that leaves us to our next service, which is API Gateway. So if I go to API Gateway, so API Gateway, this is basically a way to map URLs. So like you have a URL and you want to map like /users to a particular resource in Amazon, okay? So what you typically do if you're using like serverless and Lambda is you have an API gateway in front of your Lambdas, and then it's going to map different URLs to different Lambdas. Okay, so it sounds complicated, and it can be, unless you're using like the serverless framework or something like Claudia.js to just go ahead and deploy and set up your API gateway for you. And you can also set up custom domain names. Let's see. Oh yeah, the API Gateway supports a WebSocket API as well, so you can actually do WebSockets on Amazon, which we are doing in this project that I'm working on as well. Yeah, I don't really know what else I could talk about this, but I mean, anytime you need to actually like have physical like HTTP endpoints that need to map to Lambda functions, and I think you could map them to other Amazon resources as well. Let's see what it says here. Helps developers create and manage APIs to backend systems running on EC2, Lambda, or any publicly addressable web service. Okay. You could dive into it more, but it's just if you need to publicly allow people to access your like internal Amazon services, you're probably going to be using this if you use Lambda. Let's just be honest. So check it out. So we did Lambda, we did API Gateway. All right, CloudFormation. So if you're using that serverless library I showed you, behind the scenes that uses something called CloudFormation, which is a code as infrastructure tool provided by Amazon. So again, another term I use, code as infrastructure. Basically, you write code, and when you run that code, it tells Amazon Web Services what to host, right? So you could write some code that says, I want an EC2 instance with 4 gigs of RAM. I want an Elasticsearch cluster. I want 4 S3 buckets. And when you execute that code, it's going to go up to Amazon, or it's going to tell Amazon to spin up all these resources for you. That is what CloudFormation can be used for. And these are kind of split up into something called stacks, which you can basically create a stack. You define what resources you want in that stack, and then Amazon will just create them all for you. And then if you want to get rid of them all for whatever reason, you can go and you can delete the stack. So let's say you have 20 S3 buckets, 15 EC2 instances or whatnot. You can just delete the stack and it's just going to get rid of all those. Again, the serverless library is going to be using CloudFormation behind the scenes to spin up all your Lambdas, to create your API gateways, and whatever else it needs to do. All right, so we talked about front-end stuff. We talked about back-end stuff like running your Node code or your Python code or whatever. But when it comes to web applications, you typically need a place to store your data, right? So this is why you need something called a database. So I'm going to talk about something called DynamoDB, which is a Amazon solution. So I don't think you can find this anywhere else other than Amazon. But DynamoDB basically allows you to create tables. I think it's a key value store. The DynamoDB can be really confusing, but it's basically a key value store where you have a key that uniquely identifies some data, right? So let's say you have like user IDs. So your user ID would be your primary key, and then you could have your sort key be various things that are associated with your user, and then you just store data into it. So it's like, it's a form of NoSQL. It's kind of confusing to learn, to be honest with you all. And when you start using it, you are going to be like, yo, I should just use MySQL, or I should just use a SQL database because it makes more sense. But when you get the hang of it, DynamoDB is really cheap to use and is really efficient in terms of like doing big data, I guess you could say. So we use this at work. We basically store, all of our data inside DynamoDB. We have global tables set up, so basically you can have tables in different regions and the data syncs between the regions. You can have backup set up, which we do as well, just the backup data up to, I think it's like a 28-day period. So yeah, it's just another solution for a database. You may not need to use this, you may not want to use this, you might want to be a traditional and just stick to like RDS, which we'll talk about in a second. But I would check this one out. It's really cool if you just have a simple application where you need to store some data and fetch data back. But you're gonna, at some point when your application gets larger, you're going to run into a lot of gotchas, and it's just be careful with Dynamo. So the next one is Elasticsearch. So if you're using Dynamo and your application is really big, one thing that you'll notice is that it's very hard to query for data that is not in your primary keys or your sort keys or in your GSI global secondary indices. And that's kind of getting into too much detail of Dynamo, but Elasticsearch is a search engine. It's kind of like a database as well, where you put your data into Elasticsearch and then it'll basically create indexes over your data so that you can easily search to try to find certain things. So an example could be someone enters in an invoice information, like with all their products. So it could have like their username, it could have all the products that they bought, it could be like, I don't know, toilet paper or tissues or food. And what you can do with Elasticsearch is after all that data has been put in and indexed, you can do a query and say, give me all the records where, or give me all the users that have bought toilet paper. And that will basically do a search on your data and give you back all the users. And you can do a lot of crazy queries with Elasticsearch. You can do like, I think GPS queries. You can do, not GPS, is it GPS? Coordinates? I don't know. You can do like date queries. This is a whole nother topic that you have to read up on, but just know that it's there. It's a service that you can use to spin up Elasticsearch indices. And a lot of people use this for like the ELK stack, which is Elasticsearch, Kibana, and Logstash. So basically a place to put all your logs and then to be able to quickly search through your logs. So keep that in mind. It's a cool service to use. And if there's anything I'm missing out on this overview, like call me out, or if I say anything wrong, call me out. I'm just trying to give you like a bird's eye view so that you don't feel so intimidated when you're trying to do something simple. So the next one we use, Simple Email Service. Okay, so Simple Email Service is a service that you can use to send emails, right? So a lot of applications, when you do something inside the application, you want to send out either a confirmation email or maybe like a notification email just to let the person know that, hey, like this thing is ready for you to do something with. Or hey, like you're running out of time, you need to make sure you log in and take care of something. So email services, they're pretty well known. I know you can do like MailChimp or Mailgun and stuff like that to send out emails, but it's nice that SES exists in Amazon because you can have your Amazon Lambda invoke an SES trigger or event to send off an email once a person like uploads a file or something, you know. So it's just your traditional like mailing service stuff. I don't really know what else to talk about this, but one thing that was kind of strange is when you first use this, you're in sandbox mode and they limit how many emails you can send. So you have to actually like go to customer support and tell them to take you out of sandbox mode so you can actually like use this in a real system. So that might take a day or two. So keep in mind, if you're trying to go to prod and you're still in sandbox mode, you better get that out of sandbox mode. Yeah, let's move on. ACM. So this one we use a lot. Basically anytime, let's see what this says. Anyway, so anytime you're trying to host like a public UI or API and you want it to be behind HTTPS, you can use ACM to create your certificates, and then you can basically link your, let's say, API gateway. You can link your custom domain and API gateway to use your certificate so that you can actually use HTTPS. Or for instance, I think there's another thing that we use that uses a certificate. I don't remember off the top of my head. CloudFront, yeah, CloudFront would be using certificates as well. So you create your CloudFront distribution. You probably need to attach a certificate to it so that it can host your stuff over HTTPS and stuff like that. So just keep that in mind, that you might be messing with this service to create certificates so that you can attach them to other Amazon services. Cognito. So Cognito is a service you can use to basically create user pools, and those user pools are just the collections of users who sign up and register into your application. So I don't know if I do this, what it'll give me. You have no user pools. Yeah, I'm not going to create all this stuff because I don't want to get charged a single penny for this little tutorial I'm doing. So basically, it's just if you don't want to invest a lot of time doing your own like JWT authentication system or OAuth system, you can just use Cognito and they pretty much have all that implemented for you. So they can actually give you a login page that you can kind of customize, and a registration page where a user can go in, enter their email and password, click register. Cognito will send out an email to them. They can go to their email and confirm that confirm their account through that email account, and then log in through Cognito. And then Cognito will redirect you to your UI with a token that you gotta authenticate back to Cognito. And it's kind of complicated to get set up, but it just saves you a little bit of time to not have to worry about setting up your own like authentication system. So whenever you need to authenticate users, you can use Cognito. I am not that impressed with it, to be honest. I don't think I'd recommend Cognito to anyone, but I don't know. Maybe there's just some stuff I would like improved on it. But I mean, out of the box, it provides you with a lot of functionality, a lot of cool stuff. It manages all your users for you. They can, what can they do? I don't know if they can actually change their password in Cognito. There's a lot of stuff that you actually have to like code yourself when you're doing Cognito, and I think people use something called like AWS Amplify to do a lot of that stuff. But yeah, it's a cool little service. We use it at our on our project. So all right, I'm kind of getting tired running out of steam. So let's move on. So CloudWatch. All of these different services that I've talked about, right? They all log stuff somewhere, okay? So like DynamoDB, when you're inserting records or you're doing stuff with your database, it's logging stuff. Lambdas, when your users invoke your Lambdas, it's logging stuff. API Gateway is logging stuff. Elasticsearch is logging stuff. SES might be logging stuff. But what CloudWatch is basically a way to go and look at all your logs and try to, debug. Let's say your Lambda throws an error. Well, you go into CloudWatch and you can go to that Lambda's log group and you can view the log stream and figure out, okay, what was the error, what time was it thrown, what information was attached to that error, stuff like that. And you can also do some other more advanced searches somewhere. I think it's like insights. So you can actually do like custom queries to actually search through your logs and find stuff that you want. Another thing you do is set up alarms. So a lot of times, if you're doing like cron job events, like let's say every Monday at 3 p.m. or 3 a.m. you need to run some type of Lambda function, you can set up an event, I believe, down here, and tell it, to every, on that day at that time, invoke a Lambda function. That Lambda function will run and then do its thing. So you can do some other stuff as well, like a lot of stuff I don't even touch. I mainly just do loggings. You could do alarms. So I think when something bad is going wrong in your system, you can have it turn on an alarm so that you can see it. And I believe you can have this maybe send out emails or something. I don't know. I mean, I know you can, because I've gotten it set up to send out emails when alarms are turned on. But I don't know if you can do it in the UI or if you have to attach a trigger to the alarm to trigger a Lambda function to then send out an SES email. It's kind of complicated, to be honest with you, but the main ones, I think, if you're starting off, is just logs. CloudWatch is mainly just for logs. Look at your logs and try to debug what's going wrong, and the faster you learn this, the better you're going to be with deploying stuff to Amazon. All right, so I think the last one we actually use on our project is IAM, and this one is every project's going to be using this. This is basically where you set up your user roles, your users, your permissions, your policies, to allow different users to be able to access different resources. So if you're a beginner, you might want to come in here, and this is typically what you do, is you come in here, you create a user, and you give it admin access. I would not do that. I do have a video about me doing that in the past, and what happens is you actually, if you accidentally leak those user credentials to an account that has admin access, or if you commit it to your Git repo, there are bots out there that just crawl GitHub for access keys. And someone got my access key at one time and logged into my personal account and created like 20 of the largest servers and rung up a bill of like $2,000 within like an hour. Luckily, Amazon caught it and turned off my account and refunded me the money, but just be careful. I would say before messing with anything in Amazon, make sure you actually understand your permissions and know when and why you should be setting certain permissions. But I guess don't be too intimidated by it. Yeah, so where was I going with that? Okay, so a lot of services like Lambda, you need to grant them permission to be able to access other things. Like for an example, let's say you have a Lambda endpoint that needs to access your MySQL database, or a Lambda that needs to access your DynamoDB database. You have to explicitly grant that Lambda permissions to do anything else inside of Amazon. Okay, so this is when you come in here, you might want to create some roles or policies and basically create different policies for your Lambdas that are running. I think Lambda is really the only thing that I attach stuff to. EC2, we do actually have custom roles and policies we attach to our EC2 instances. I believe you probably have to do the same thing for your containers so that your application can actually access like S3 and actually store files and retrieve files. Because if you don't set up those policies and permissions, your Lambda function is not going to be able to do anything. It's just going to be able to run some JavaScript, and that's about it. So yeah, you're more than likely going to be in this dashboard creating up users and roles and stuff like that. So those are the ones we use at work. I may have left one out or two. I don't remember. I think this is all of them. But it's a lot of stuff, honestly, and it's not something that you just learn in one day. You kind of learn it a day at a time. You maybe create a service, you mess around with it, you learn more about it, you tweak it, you fine-tune it, and then you move on to the next one, you learn more about it, and you just go down the list. And that's kind of what happens over a year or two of working on a large-scale project, is you slowly start adding these things to your project, when like your business use cases asks for them. All right, so I'm going to wrap up with these over here. And these are just some extras. I have used these on various other projects, and I think they're important to know. So let's go to SNS. SNS is basically for topics, okay? So a topic is something that you have various devices or machines that listen to a particular SNS topic, and when something sends a message to that topic, it basically notifies everything that's attached to that topic. So it's basically, like they say here, it's a pub sub messaging for microservices. So you might want to use this if you have a service over here that needs to get notified when this service is done doing some processing, or you have like 10 services that are all listening for when something finishes, right? It's a way to just basically let other services know, or other things know, that hey, it's time for you to run some code, or hey, it's time for you to do something. Now, there's really not that much more to get into here, so let's move on to SQS. So SQS is kind of a similar thing, but it uses something called queues. So a queue is basically if you think about the queue data structure, it's a place where you store messages, right? So you might have a queue that's like 100 messages long, and you have services that are reading from the queue. Okay, so here's the queue. You have like services that are taking messages one at a time from the queue and doing some processing. So you might want to use SQS if you have some type of distributed processing you need to get done. You might have a queue that, I don't know, when people are buying orders on your site, you might want to put that whole order message in a queue, and then you might have your processing services or your payment services grab those one at a time to do some work. It really all just depends. But basically SNS and SQS, you probably want to use these if you have some type of long running process that you don't want to run in your API gateway, or you don't want to run in a Lambda. Alright, so I drank some water because my throat is getting kind of dry right now, but I guess one example of why you use SQS is, let's say you have a process that takes a minute to like run, okay? So you don't want a user to hit your API gateway and sit there on the UI and wait for a minute for something to finish. You may instead want to have that hit an endpoint that creates an SQS message that is later picked up by some process that, I don't know, takes that message, runs the computation, and then after a minute passes, when it's done, you can then notify the user with like WebSockets or something, telling, hey, your process is done running, okay? And you don't necessarily have to use SQS in that particular example. You could just do an async function API gateway. The user could do some work and move on. But these two topics, like topics and queues and message systems and message brokers, I would just go read up on those because they're kind of important to know, especially when you're dealing with microservices and services that need to like talk to each other. With that being said, let's talk about one more. It's called kinesis. So this is another type of like messaging data stream system where if you have data that needs to be like processed on in a particular order, you can do something called kinesis, where you create like kinesis streams. And sometimes they do this for like, you might want to use this for like video streaming or video processing, where you have like a bunch of video data that you need to process in a particular order. Yeah. Or if you need to like do some type of throttling. So an example was like we'd have, in a project that I did before, we had like 100,000 user objects that needed to get processed all at the same time. And we tried using like, I think SNS. So basically you just send off a bunch of SNS messages. Those are run, actually no, I think it was SQS. And those get picked up by Lambdas, and those Lambdas would just basically run. Now the issue with that is Lambda has a really high concurrency, right? I think you can run like 1,000 Lambdas at the same time. So it would grab all those users and try to process them at the same time, and that would end up crashing a you know, a MySQL database or a Microsoft SQL database because we're kind of overloading it. So we ended up switching to kinesis to throttle that. I think they added some type of like rate limiting in Lambda now, but they didn't have that back then. But basically we used kinesis, and we told it to like have like a max of 10 shards or 5 shards, so that it wasn't processing all this data extremely fast. But yeah, there's probably better use cases for kinesis. I just kind of touched the surface of it, and I wasn't really sure what I was doing at the time. So yeah, I guess it's good to check out. Another one is Amazon MQ. I haven't used this, but I think it'd be interesting to check out. But again, it's just another messaging system where you can have services subscribe to probably queues or topics, and then you can publish those queues and topics to notify other services. I haven't personally used this one, so use at your own risk. Let me know if you have used this. I have used RapidNQ and ActiveMQ on my first project that I got out of college, and it was pretty cool. It's like you basically send messages, and those messages can be picked up later and processed on and stuff like that. And it's just a way to like allow all of your services to communicate with each other. You know, and it's like 1:18 in the morning right now, so I'm running out of steam, I'll be honest with you. So I'm going to do the last one, RDS. This is for relational databases. So if you got MySQL, if you're running MySQL, or you're running, I don't know, Aurora or whatever else, Postgres, you can come in the RDS and you can spin up a Postgres instance of a certain size. I think you can do some type of like clustering. They take care of all that complicated stuff for you, for like scaling up databases, like fault tolerance, all this other stuff that is pretty complicated, but they take care of that for you. And so if you're interested in setting up a MySQL database or Postgres, you could check this out. But I would warn you, I think this is extremely expensive. Like, it might be easier if you're like beginner and you just want to spin up a MySQL database. Just get a DigitalOcean droplet, install MySQL, and host it there. Unless you know you're going to get a ton of traffic to your application, then scale it up later or migrate it to like something like this. But you know, they have like snapshots and cool stuff that you can do with your database here. I haven't used this. We looked into it. We were thinking about using it, but we decided to go with DynamoDB because it's cheaper. But yeah, let me know if you used Amazon RDS, if it's pretty cool. I'm assuming it's just, you know, you host a MySQL database and then you're good to go. Alrighty, so that is my overview of what Amazon Web Services is, why you might want to use it, what you can use it for, and again, there's so much more behind the scenes. Like, I only scratched the surface of all the different services they provide. So I'm sure there's a lot of stuff out there that's really interesting that I have not used yet. So if you have used these, you know, leave a comment below. Let me know. I'm always interested in learning more. Actually, I've used X-Ray before. Let's see what else there is. Glacier is basically just a way to store your S3 files if you don't use them that often. This Internet of Things stuff is probably more if you're doing like mobile app development, so like on your iPhone or Android device, but I haven't really looked into that. I know they have something called like code deploy and code commit, code pipeline. This is like your CI/CD solution. So if you use like Jenkins or Travis CI or Circle CI, I think this is like one of the competitor solutions. What else is there? I know they have like something for AI as well. I don't know. They have a ton of stuff. So if you have information or any suggestions of other services I should check out, let me know. But yeah, let me know how this overview was. If this overview was pretty good, let me know. I'm kind of worried that I didn't give enough detail, or I was kind of all over the place, but whatever. I could probably make this later, but at least there's a video where I explain some Amazon stuff. So again, this is a Web Dev Junkie video. Thank you so much for watching if you're still watching this video. And be sure to leave me a thumbs up and subscribe if you're new to this channel, and leave me a comment and tell me how awesome this video was or how bad this video was. Anyway, Have a good day.